Good morning. This is the very last video that we have on this particular unit, and this is 7.13 Modeling with Polynomial Functions. And you're going to be able to write the equation of any polynomial and when you're done with this. And so what you're going to be looking for, of course, are the x-intercepts to find out where the graph crosses the x-axis. And you're going to use the multiplicity. You're going to use the multiplicity so that you can come up with the proper number of bubbles that you're going to have. And you're also going to be having a specific point here. Okay? So that's what we're going to be doing with this. And just remember, we're going to be making bubbles out of this. Let's go ahead and try it out. Okay? All right. So first graph that I've got here, let's take a look at it. Get a little closer. All right. So it appears that the x's are right here, and right here, because these are the x-intercepts, or the zeros. And so that's where they cross the x-axis. So it looks like we've got an x equals -3, and an x equals 2, and an x equals 5. And if you remember what we're going to do, we're going to look for the multiplicity. So each of these passes through the x-axis. So because they pass, remember to pass, these are all passes. So that means that this is a multiplicity of 1. All right. So let's just go ahead and set these up. We know if x is -3, then our bubble is going to be x plus 3, and it's a multiplicity of 1. And then over here, x equals 2, so we're going to have a bubble of x minus 2 with a multiplicity of 1. And then this is x equals 5, so we're going to go back and bring the 5 over with the x, and so that means we're going to have a bubble of x minus 5 times 1. And we're going to multiply all of this together times a, right? These are all multiplied together. And our a, if you'll remember, that's going to determine how wide or how scrunched or high or the graph is going to look. Okay? All right. So you're going to use also a specific point, and the point is down here. So that's the other thing we're given. And it's kind of hard to see this, but this is at x is 0 and y is -15. Okay? We're going to use that point. So we're going to use a specific point. So we're going to use, and that's the specific point, we're going to use 0, -15 to solve for a. That's the a. This is the a over here. Okay. All right. So now that we know that we're going to do that, let's go ahead and get started. So -15, right, is going to be our y, and that equals a times, now let's see here, this would be 0 plus 3 times 0 plus, 0 minus 2 times 0 minus 5, okay? And so remember that those zeros, they're going to go away, really, right? They're going to go away. So you're going to be left with negative 15 equals a times 3 times negative 2 times negative 5. Okay. All right, let's clean it up. So negative 15 is going to equal, let's see, what's 3 times negative 2? That's negative times negative 5 is positive 30. So we end up with 30a. And then we're going to divide by 30 on both sides here. And so this cancels, and you're going to get, it looks like negative 1/2 is going to equal your a. Now, are we done? No, because we have to then take this negative 1/2 here, and we've got to plug it back in up here for the a. So we're going to do that now. Let's see here. Y equals negative 1/2, because that's our a, times x plus 3 times x minus 2 times x plus, x, let me use a little white out here. X minus 5 is what we want. Let's fix that. So x minus 5. All right. So this is our what we call specific model. It's a specific model because we used a specific point. We use this point here, right? To create this model, all right? So we're putting everything together when we do this, and that's how come we've got a specific model. Now, we can check this. We can check this. So what we can do is we can, let's see if I can get this over where we can see everything. We can go ahead and type this in. So let me type in this equation into our graph. So let's turn this on. Let's clear this out. It's a different graph. So let's clear it away. All right. So I'm going to type in parentheses negative 1 divided by 2 for negative 1/2 times parentheses x plus 3. So x plus 3, close that parentheses, times x minus 2, x minus 2, close parentheses, and then times x minus 5, parentheses, x minus 5, close that parentheses, and then we would graph that. Now, you can't see the whole darn thing, so what we're going to need to do is we're going to need to change our window because we've got stuff that's off the graph. I want to see the top and the bottom of the graph. So let's go over to our window and let's change our x max to, let's change it to 7. So let's scroll down here. Oh, x minimum, let's change our x minimum to negative 5. So let's type in negative 5.
You're coming and you're helping.
And, whoops, that's not what I wanted to do. So let's clear that. Why did it do that? I don't know. Okay, so x, I want to change that again to negative 5. So negative 5. Doesn't want me to go down that way. Oh, I know why. Let's go ahead and clear that again. Window, negative 5. Okay. That should allow me to go down like that. I think my graphing calculator is starting to die on me here. Okay, window, x minimum. Let's go down here if I can see if I can get down to, well, it let me into the x maximum. Okay, so let's try -7, x max, +7. Actually, it's the y's that we need to worry about. So let's just go down to do the y's because that's what was getting cut off. So let's do -20. -20. Okay. And then the y max. That's it again. -20. And I want 10. So maybe I can just get away with this gimpy thing. Let's clear this again. Window. Drop down here to let's do this, just the -20. That's probably the minimum that we need. So -20. Okay. Now let's go back to the graph. Doesn't want to do it. Y max. Y min. -20. Back. -20. Hit enter. Well, guys, all right. So obviously I can't do that with this thing because it is not working right now. I'm just going to have to, I'll try batteries later, see if that works. But my little graphing calculator is not going to work for us. So I'm going to just put it to the side. We got the basic graph off of this. I might be able to see the y-intercept. So I'm going to try one other thing before I give up completely on the graph. So here was the equation, here was the graph, and what I can't see is this point down here, which is what I really wanted to put in. But let me try trace in any event. Let me put in trace, and I want 0, -15. So if y is -15, x is 0. So that at least tells you, if you look at this, if you put in trace, it's going to give you the y-intercept. X is 0, y is -15, which is what we have here exactly. So we at least can see that. All right, so we've got our specific model here. Let's move on. And we'll deal with that little issue with graphing calculators later. All right. So got another little graph here, and so let's see what we've got. We have a point here at x is 1, y is 0. So we'll write x equals 1 up here. And we've got one down here at, looks like x is 5. X equals 5. All right. And so we also have a y-intercept. Looks like crosses here. And if you calculate it, this is 1, 2, 3, 4, 20, 25, 30. This is 30. So this is x is 0, y is 30. So we know that's the y-intercept. So that's the specific point that they give us. Okay. All right. So we now have three points, two of which are the x's. So if x equals 1, now here you see what's happening here is this is a bounce. So this is a bounce. So this is a multiplicity of 2 because it's a bounce that's happening, bouncing off. And it's bouncing off over here, and where x equals 5. So again, we have a multiplicity of 2 because we've got a bounce. Right? And let's set up our equation then. Y equals our A times, and then we're going to, if you remember, we're going to find out that x equals -1 when we move it over. So x minus 1. And then it's going to be squared because why? We have this multiplicity of 2 here, right? And then we're going to have, this is going to move over. The 5 is going to move over. So you're going to have x minus 5. And it's also squared because we have a multiplicity of 2. Okay? So, good. Now we want to use this specific point. So, use 0, 30 to solve for A. Right? Okay. And, all right. So now when we do this, of course, what's going to happen is our x is going to be 0. It's going to be 0, and this x is going to be a 0 when we use 0, when we use 0, 30 to solve for x. I'm sorry, to solve for A. We're going to end up writing this as 30 because that's our y for that specific point. And 30 equals our A again. And then since this is x minus 0, well, since this x is going to be 0, we can really just change this to -1, right? Squared times -5 squared. All I did here was it with the binomial. Since I knew that the x was going to be 0, I just took it out and left the -1 and the -5. And we're squaring those. All right, let's simplify now. So 30 equals A times, let's see, -1 squared is +1. And -5 squared is +25. All right, so 30 equals, this is 1 times 25, so 25A. And so we're going to now divide on both sides by 25. And we're going to reduce by 5s here. So this is going to end up being 6 divided by 5, okay, when we reduce. And that's what equals A. All right, so our equation should be y equals, our A is 6 over 5. And then we have this x minus 1 up here. And we had a multiplicity of 2. So it's squared times x minus 5, multiplicity of 2. So it's also squared. So this is our specific model again. All right? And again, we can check this out. Unfortunately, I can't check it out because my graphing calculator doesn't work right now. But if you were to, again, go ahead and try to figure out the specific window size so that you could see this properly, we would be in good shape. Let's just see if we're within our parameters here. We're up to 20 here. I don't know, it might or might not work. Let's try. We'll do it just once, and then this is going to be our last gasp at trying to do this. So let's see here. Turn this on here. And we're going to put in our equation. So we've got 6 divided by, let's put this in parentheses. Parentheses 6 divided by 5 times parentheses x minus 1 parentheses, and then we're going to square it, so to the second power, and then parentheses x minus 5, so x minus 5, close our parentheses, and we're also going to square that. Okay, so let's go up to the graph, see what we can see here. Well, we just can't see the top of our graph, and it is awfully small. I would love to be able to change the size of this graph, but as you saw before when we tried to do the window, it would not work. We could try trace and see if we could come up with where the y-intercept would be. So there it shows you if x is 0, y is 30, and by golly, that was the number that we were using. So that at least checks. So we know that checks. All right. So let's go to the next one. We're going to go a little faster now. And I'm not going to work with a graphing calculator anymore. So looking at this one, we've got a point here at -2. So let's write x equals -2, and then we've got another one here at, looks like x equals 5, right? And both of these, well, this one's a pass, and where x equals 5, that is a bounce. So two different things happen. So over here you've got a multiplicity of 1. Over here, though, you have a multiplicity of 2. Right? So y is going to equal a times, okay, this will become x plus 2. Okay. And since it's a multiplicity of 1, we'll just leave a 1 there, even though we don't really need it. And then over here, this is going to become x minus 5 in parentheses, or in the bubble. And it's a multiplicity of 2, so we're going to put a squared there. Okay. All right, so then for our specific point, we're going to use 0, 100. Because if you look up here, this is where the graph crosses the y-axis. So we want to use 0, 100 up here. And we're going to use this to solve for A, our specific point. Okay. So we're using the specific point to solve for A. All right, so let's rewrite this then as 100. Our y is now 100 because we're using that specific point, equals A times, this becomes 2, right? Because, why? Because you've got to remember that this is going to become 0. If this is going to become 100, its x has to be 0. So x is 0, y is 100. So the x here is 0. Here and here. Okay? So we'll put that in. So since it's there, we can just simply take the 2 down here and put that in, because you don't need the 0. And over here, we forget the 0 now and put in -5. So this is 2 to the 1, and this is -5, and we have a 2 here, so it's squared. All right. So let's simplify now. We have 100 equals a times, this is 2 times, so -2, oops, sorry, +2, times, and this is -5 squared, or 25. Because -5 times -5 is 25. All right, 2 times 25 is 50. So we get 100 equals 50a. And then we're going to divide by 50. So divide by 50 here and here. And when we divide 100 by 50, that's 2. And 2 equals, this cancels, a. Okay? Okay, so now we know what a is, so we're going to take that and we're going to again plug it in over here for the a. And we're going to rewrite our equation. So we're going to write it as y equals 2 times the x plus 2. And we know it's to the 1. I'm not going to bother with the 1 now. And then x minus, times x minus 5. And we said that's squared. All right. So this is our specific model. And I will leave it to you and your graphing calculator to check that. But it will match. Okay? All right. So let's see. I think this is our last one. And so let's see. We've got an x at -2. We've got a x at, looks like 6. So x equals -2 and x equals 6. And we also have a point over here on the y-axis, which is going to be our specific point. Let's see, 5, 6, 7, 8, 9. It looks like at 8. Yeah. So this is, x is 0, y is 8. Right? All right. So x is -2. It passes through, so it's got to be a multiplicity of 1. So multiplicity of 1. And then over here, it's also a pass. X is 6. So that's also a multiplicity of 1. And so we're going to write this equation. Y equals a times x plus 2, because again, we're going to move the -2 over, and it's to the 1, times x plus x minus 6, because we're going to move this 6 over to the other side, and it's also a multiplicity of 1. All right, so we're going to use the specific point, so that means we're going to use an 8 for our y, and we're going to change the x's here to 0. Right? And so we're going to write this out as 8 equals a, and then remember, since this is 0, we're left with a 2, so times 2, and it's to the 1, and then this x is a 0, so we're left with -6, and that's also to the 1. So simplifying that, 8 equals, let's see, 2 times -6 is -12, so that's -12a. We're going to divide both sides here by -12. And 8 divided by 12 will simplify to, let's see, both of those you can divide 4 into, so 2/3, and it's negative. So negative 2/3 is going to equal your A. All right. So we've got the A now. Let's write our equation. So y equals negative 2/3 times, here's our original x plus 2 bubble. It's to the 1, so we aren't going to put a 1 there. Now we're just going to keep it clean, and then times x minus 6. And that's also to the 1. So we can just assume that. So that is our specific model again. Of this graph where you know a specific point. So you got a specific point. And a specific point gives you the specific model because you're able to put that information into this equation and simplify it to get the A, and that gives you this negative 2/3 here. And that's what we're doing with all of these. So we are done. And so you're going to do this again with the Delta Math assignment I give you, which is not too terribly long. And you're done for this particular lesson, and you're going to soon be taking a test. All right. Thank you very much. Bye-bye.